There is an easy way to solve this question. The problem, though, with the easy way to solve it is we don't learn anything from that. So I'll show you the easy way at the very end. But before we go there, I want to really try to learn as much as we can from this question. It's testing a very important concept from kind of where number line reasoning and divisibility and remainders meet. It's kind of a combination of those two ways of thinking. So I want to focus on that today. And I want to start with a much easier version of this question. Okay, and I ask you, what can you tell me, if anything, about the divisibility of n squared plus n? So we simplify algebraically to n times n plus 1, and then you correctly identified that now we're looking at the product of two consecutive integers, positive integers, on the number line. And you mentioned that since they're consecutive, one of them will be odd and one of them will be even. And that's correct as well, because that alternates on the number line. And my question was, what can you say, if anything, about the divisibility of n squared plus n? So given that it's the product of two consecutive positive integers, what can you say about the divisibility of that product? That's right. Really, the only thing we can say about the divisibility of the product of two consecutive integers is that it will be divisible by 2. And why is it divisible by 2? Because one of its factors is going to be even and one is going to be odd. I don't know which one is which, but it doesn't matter, because when you're multiplying, imagine that n has a prime box that looks like this. There's some stuff in it, I don't know what. N plus 1 also has a prime box, and that one looks like this. You correctly identified that there would be nothing in common between those boxes. That's true, because we're just adding 1. So whatever n is a multiple of, n plus 1 would have a remainder of 1 for that factor, if you were to divide by that factor. But we do know that one of these boxes contains at least 1 2. There is a 2 in one of them. I don't know in which one, but when you look at the prime box of the product, it's going to have everything from the box of n and also everything from the box of n plus 1. So wherever that 2 was, it for sure will have a 2 in the product n squared plus n. So the conclusion from all of that is that the product of two consecutive positive integers has to be even. In other words, it has to be divisible by 2. That's the foundation of what this problem is testing. You're saying if this is the prime box of n, what will n plus 1 have? I don't know. If we know that this is the prime box of n, then we can infer the prime box of n plus 1. It would just be 27 to the power of 1. N squared plus n would have 2 to the 1, 13 to the 1, 27 to the 1. Yeah, n squared plus n would have the entire contents of these two boxes. Yeah, so for example, if in our example here, n is a multiple of 2, and n is a multiple of 13, just with the example that you suggested, right? Mm-hmm. If you were to try to divide n plus 1 by 2, what would be your remainder?
1.
And if you try to divide n plus 1 by 13, what will be your remainder?
1.
And if you try to divide n plus 1 by 26, what will be your remainder?
Oh, okay. 1.
Yeah, you'll have a remainder of 1 regardless of which of the factors of n you're trying to divide by. This is also why they don't have a common factor. Right? They're just too close together to have a common factor, because whatever factor n has, n plus 1 will be 1 unit to the right of a multiple of that factor, because n is a multiple of that factor.
So the only factor would be n plus 13. That would be the next number, which I would have 13 as the factor.
Correct. Or n plus 2.
That would have 2 as the factor.
That's right.
Okay.
Because we have this cyclicality on the number line, right? Every other number is a multiple of 2. Every 13th number is a multiple of 13, and so on. So I wrote here a question that's trying to mimic the original GMAT question. except here instead of divisibility by 3, we're looking at divisibility by 2. See if you can apply what we just saw to this question. When you say properties, when you say grouping, can you be more specific? What is the lens through which you're looking at these numbers on the number line?
One of them has to be even.
That's exactly right. So you're using a lens that is interested in divisibility by 2. Through that lens of divisibility by 2, you could split numbers into two camps. Either their remainder is 0 when you divide them by 2, also known as even numbers, or their remainder is 1 when you divide them by 2, also known as odd numbers. There aren't any other integers in the world. Right? All of the integers in the world fall into one of those two camps, including 0. 0 is an even number because you can take 0 items and split them evenly into two groups. Each group would have an integer. Each group would have 0, which is an integer. So literally every integer in the world is either even or odd, and that's the lens that you're using to solve this question. You're saying through that lens, numbers either have a remainder of 0 or a remainder of 1 when you divide them by 2, and we know how those numbers relate to one another on the number line, because on the number line, every other number will match. Every other number will be from that same camp. So to pick out an answer choice that for sure will be even, all you have to do is guarantee that you're taking two numbers from two different camps. If you take two numbers from the same camp, well, that camp might be odd numbers. And if you took two odd numbers, neither of which has a 2 in its prime box, and you multiply them together, you still won't have a 2 in your prime box. This is why odd times odd is odd. I don't like to memorize that. I like to instead just say, well, odd means no 2's in the prime box. Take another number that has no 2's in the prime box. When you multiply them together, the prime box of their product still won't have any 2's in it. I mean, you don't magically get a factor of 2 from thin air. Exactly, those are the two camps. One camp has numbers that have a remainder 0 when you divide them by 2, and the other camp has a remainder 1 when you divide them by 2. And the problem with answer choices A, B, D, and E is they're all selecting numbers from the same camp. N and n plus 4 are the same type of number in the context of divisibility by 2. N and n plus 4, because they're 4 away from each other, they'll either both be odd or both be even. And if they are both odd, the product won't be a multiple of 2, so I'd have to eliminate answer choice A because of the word must. Right? The question had the word must in it. I can't guarantee that answer choice A will be even. It could be even. If n and n plus 4 are even, it will be even, but if they're odd, it won't be. And the point is that we know n and n plus 4 belong to the same camp. You can maybe see it more clearly if you draw a number line and you plot them on a number line. Here's n plus 1, n plus 2, n plus 3, and n plus 4. So if n happens to be odd, if it's odd, then this one will be odd and this one will be odd as well. And the same goes for any pair of numbers for which the distance between them is even. So that goes for A, B, D, because in D, the n plus 3 and n plus 7, they're 4 apart. They're 4 away from each other, so they belong to the same camp, and same goes with E. They're 10 apart. 10 is an even number, so n plus 10 and n plus 20 are either both even or both odd. The good thing about answer choice C is that because they're 7 apart, they came from different camps. And there are only 2 camps. So we know there are only 2 camps. These came from different camps. Guess what? One of them is odd and the other is even. I don't know which is which, but it doesn't matter because the question wasn't about n. The question wasn't about n plus 7. The question was about the product of n times n plus 7. So as long as I know that one of them is even and the other is an integer, then the product will be even. And that's why the correct answer here would be C. There was one more step you could have taken and you didn't, and that's really the lesson we want to take from here. You started off well. The step you didn't take was you missed a pattern, right? When you look at what are the numbers that are the same, meaning from the same camp, they're always an even number of units away from each other. And that was a pattern that you missed. Am I right? Is that what slowed you down?
Yes.
Yeah, so it's important to notice that pattern and to think about it. And it really comes back to the cyclicality of divisibility on the number line. Anytime you're talking about divisibility, there's a cycle. There's a pattern that repeats itself. So for example, if we're talking about a number which, when you divide it by 7, you get a remainder of 3. So let's say n is some positive integer. When you divide it by 7, you get a remainder of 3. Because we're talking about divisibility, you're going to have a repeating pattern here. You'll have a cycle. The length of the cycle will be 7, because that's the divisor that we're dealing with. So it'll be every 7th number. And you could start from 3, because 3 divided by 7 gives you a remainder of 3. So if they told you n is a positive integer, you would say, well, it could be 3. And on the number line, this will reoccur every 7, because that's our divisor. So it'd be 3 or 10 or 17. I just keep adding 7 over and over again. These are the possible values of n.
On the number line.
Yeah. How come the gaps? Here the spacing is 7s, and in the previous case the spacings were 2s. Why is that? All right, in the previous case we said, oh, every other number will belong to the same camp. Here it appears that it's only every 7th number that would match the description at the top. Why is that?
I think it's because your divisor is 7. Your divisor is 7 now.
That's right. In this case, the lens through which we're looking at the world is the lens of divisibility by 7. In the previous question, the lens we were using to look at the world was the lens of divisibility by 2. So with the lens of divisibility by 2, there's only 2 camps. But with the lens of divisibility by 7, there are actually 7 camps. Because if you're an integer and I divide you by 7, there could be 7 different outcomes. Your remainder could be 0 if you are a multiple of 7. Or your remainder could be 1 or 2 or 3 or 4 or 5 or 6. So that's a total of 7 different types of numbers in the context of divisibility by 7. And by the way, the reason that we have the words odd and even is because there are only 2 camps for divisibility by 2. Right? Either you are divisible by 2 or you have a remainder of 1. And so a long time ago, before I was born, people decided to name them even and odd. But with divisibility by other divisors greater than 2, there's multiple camps. And we don't have names for them because, you'd need 7 different names for, to describe numbers in the world of divisibility by 7. It would get out of hand very quickly. So instead, we use the word remainder. When we say, when you're divided by 7, your remainder is 3, for example, in this case. That's a way to describe a camp. Through the lens of divisibility by 7, when we look at the world, we can describe numbers that have a remainder of 3, and this is what they would look like. They would belong to this set. You might notice it's an arithmetic set, also known as an evenly spaced set, and that spacing will come from the divisor. That's the spacing among the numbers, because that's the pattern. That's the cyclicality on the number line.
The same.
You started off well. You said that n plus 210 will be from the same camp as n.
Right.
That's correct, because 210 is a multiple of 7. So n and n plus 210 will come from the same camp in the world of divisibility by 7.
And we don't know the remainder for this, correct?
We do. We were given that the remainder is 2.
Oh, okay. So n, the remainder is 2.
Yeah, when n is divided by 7, the remainder is 2. We want to know what's the remainder when we divide n plus 212 by 7.
Yeah, so then it's 4.
That's right. So we could draw a number line and we could say, look, here's n plus 210. I know that those have the same remainder when divided by 7 because the distance between them is a multiple of 7. So we know that this one has a remainder of 2 when we divide it by 7. And where is n plus 212? 1, 2. 2 units to the right of n plus 210. So the remainder here would be 4. I would say that the camp is named by the remainder. Like we could name the different camps by the remainder. We would say, in the world of divisibility by 7, this camp is remainder 3. And then you could talk about all the different numbers that belong to that camp. So before we go back to the original GMAT question, I want to run a thought experiment by you. I want you to imagine that we're going to play a game. In this game, there are 3 buckets, each of which has beads in it. In one bucket, all the beads are blue. In the second bucket, all the beads are white. In the third bucket, all the beads are green. Now I'm going to blindfold you, so you won't know which bucket is which. And I'm going to allow you to take a total of 3 beads from the 3 buckets in front of you. What would be your strategy if in order to win, you must pick at least one white bead? You can't see. You can feel with your hands the 3 buckets. You could feel them. You could pull a bead out of any of them. You only win if you get at least one white bead. You get a total of 3 beads to pull out of these 3 buckets. What would be your strategy? That's right. The strategy of choosing one bead from each bucket will guarantee that you have one white bead. In fact, it guarantees you have exactly one white bead. But it doesn't matter. You win as long as you have at least one. So whether you have 1 or 3 doesn't matter. Any other strategy, you might lose. Like if you take 3 beads from one bucket, you might get 3 white ones, but you might get 3 blue ones. So you can't guarantee a win if you take all 3 beads from one bucket. And even if you take 2 beads from one bucket and 1 bead from another bucket, well, maybe you got unlucky and the one bucket you didn't grab from, it was the white one. So the only way to guarantee a win is to choose 1 bead from each bucket. I want you to keep that insight in mind as we go back to the original question that we started the day with. Think about the camps. In this case, what lens are we using to look at the world? There are 2 things you said that I'm a bit confused about. One was you mentioned odds and evens, which is outside of the scope of this question, because this question is dealing with divisibility by 3. And in the context of divisibility by 3, odds and evens they're not interesting. For example, if you tell me some number is odd, can I tell whether it's a multiple of 3 or not? No, maybe it is, maybe it isn't. Like 50-50 chance. If you tell me that a number is divisible by 3, can I tell whether it's odd or even? No. If you tell me this number when you divide it by 3 has a remainder of 2, does that tell me whether it's odd or even? No. And the reason that the world of divisibility by 2 and the world of divisibility by 3 have nothing in common, and you can't make any inferences from one to the other, is because 2 and 3 don't have any common factors. If you were talking about divisibility by 2 and divisibility by 6, now we can make some inferences. For example, something that is divisible by 6 is definitely divisible by 2. And the reason I can make an inference in that case is because 2 and 6 have a common factor. So if there's a common factor between the divisors, you might be able to make some inferences. And that's why in that case, we would be able to make some inferences going from one world to the other. And so you understand that in the world of divisibility by 3, there are 3 different camps. There's the camp of remainder 0, also known as multiples of 3. There's a camp of remainder 1. So those are all the numbers that are just 1 unit to the right of a multiple of 3. And finally, there's the camp of numbers that have a remainder of 2 when you divide them by 3. A way for me to guarantee that the product of 3 positive integers will be divisible by 3 is if I can ensure that I have one member from each camp. I might not know which member came from which camp, but as long as I've guaranteed that I have one from each, then the product will be divisible by 3. So that's very similar to the story about the 3 buckets. I want to guarantee that I have at least one white bead. In the analogy here would be, the white bead means remainder 0, and maybe the blue beads are remainder 1, and the green beads are remainder 2. But as long as I have a white bead, I'm good. And the strategy was, since I don't know which bucket is which, to grab one from each bucket.
Right.
And so the other insight we had today that we're using here is that when we look at the number line through the lens of divisibility by 3, the spacing among members of the same camp will be 3. So every third number will belong to the same camp. And this is because the divisor of this world is 3. So every third number will be a multiple of 3. And if you start from a different spot, let's say from a remainder 1, from there every third number will have remainder 1. You start from a different spot that has a remainder 2. From there every third number will have a remainder 2. And then when we look at these answer choices and we start with A, we do notice quickly that n and n plus 1 came from different camps because they're one away from each other. And we know that the next number on the number line, n plus 2, would give us that third camp. So if only it was n times n plus 1 times n plus 2, we'd be good. But it's not n plus 2, it's n minus 4. So we need to ask ourselves, does n minus 4 belong to the same camp as n plus 2? Or does it belong to a different camp? And when you draw n minus 4 and n plus 2 on the number line, what you realize is that they are how far apart? Here's n minus 4. Here's n minus 3. Here's n minus 2. Here's n minus 1. Here's n plus 1, and n plus 2. So how far apart are they? 1, 2, 3, 4, 5, 6. Now a faster way to do that is to take n plus 2 and subtract from that n minus 4. That will also give you the distance between two numbers on the number line. So that's n plus 2 minus n, and then you've got the minus minus. That turns into plus 4, and that's 6. That's maybe the faster way to find out how far apart they are. So because the distance between n minus 4 and n plus 2 is a multiple of 3, and 3 is that all-important number in this question because that's the divisor that we're dealing with, and it turns out that n minus 4 and n plus 2 came from the same camp. So back to that bucket analogy, now I know for answer choice A, I do have one bead from each bucket, and that's why it's the correct answer. Now just for our purposes, let's see why B, C, D, E cannot guarantee that you'll have a multiple of 3. In the case of B, you have two members coming from the same camp. It would be like if you took two beads from one bucket and one bead from a second bucket. Well, you can't guarantee you'll have a white bead. And why do I say that they came from the same camp? Because the distance between them on the number line is 3. They're 3 apart from each other. So that means they came from the same camp in the world of divisibility by 3. What about answer choice C? Look, n and n plus 3. How far apart are they? 3. Can't guarantee. Can't guarantee. D, you've got n plus 4 and n minus 2. They came from the same camp. Eliminate. And finally, n and n minus 6 came from the same camp. The distance between them is a multiple of 3. That means they came from the same camp in the world of divisibility by 3. Eliminate E. Does that make sense? So my hope is through going through this question, we're deepening our understanding of number line reasoning and divisibility and remainders and how those can be used together to get quick insights on questions like this. I did promise that I would show you the easy way to solve the question as well, so I'll do that next. But I want to warn you, when you're at home preparing for the GMAT, never be satisfied with picking the right answer if you didn't learn anything from the question. That's exactly what this solution that I'm going to show you, that's exactly what it does. It gets you to the right answer. Well, that's nice, but I didn't learn anything from it. Look, I know that n is an integer greater than 6, so for example, it could be 7. And if it's 7, then we have here 7 times 8 times 3. And that would be a multiple of 3 because we have a 3 there, so I can't eliminate A. Answer choice B would be 7 times 9. That's a multiple of 3 right there, so I can't eliminate B either. Next one would be 7 times 10 times 2. Aha, that's not a multiple of 3, so C is gone because of the word must. Okay, they're asking which of the following must be, and I just proved that C might not be, depending on the value of n. Because if n is 7, C is not a multiple of 3. So we can eliminate that one. Next we have 7 times 11 times 5. None of those is a multiple of 3 either, so D is gone. And finally we have 7 times 12. Oh, 12 is a multiple of 3. I cannot eliminate E. So using n equals 7, we eliminated 2 answer choices, and now we'll try n equals 8. So if n is 8, we have 8 times 9. Oh, 9 is a multiple of 3. Can't eliminate A. Next, we have 8 times 10 times 7. Ah, that's not a multiple of 3 because none of them is. I'm not checking C and D because they're already gone. And the last one is 8 times 13 times 2. That can be eliminated as well because none of those numbers is a multiple of 3. And now I can pick A. So you can see this absolutely can be done in under 2 minutes. Probably in under a minute and a half. And it's a perfectly acceptable solution at the test center. But as I said before, if this is how you're solving the question at home, then you've learned absolutely nothing from it, which means you're not studying effectively because you didn't use this question to improve your reasoning. In data sufficiency, should you start with whichever statement is easier? Absolutely, yes, 100%. I go into all the reasons why that's a good strategy in section 2 of my book, which you have access to. So if you haven't yet read section 2, I go into really everything there is to know about data sufficiency. So both the most basic stuff, but all the way to the most advanced reasoning that you can use for data sufficiency. For example, if you realize that statement 1 implies statement 2, and statement 2 implies statement 1, then you can eliminate 3 answer choices without even reading the question. A, B, C are all gone automatically. I go into all of that in the book, so definitely check out section 2. Among other things, I explain there why, yes, you should always start with whichever statement is easier, and I would say about a third of the time, I start with statement 2. So about 1/3 of the time, the statements are similar in difficulty level, and then I just start with 1. And then 1/3 of the time, 1 is easier, and 1/3 of the time, 2 is easier. So 1/3 of the time, I start from statement 2. I believe that you should start, before you read the question, you should start by glancing quickly at the answer choices just to get a sense of what you're going to be solving for. Because if the answer choices say, for example, 10% profit, 15% profit, 18% profit, 5% loss, 20% loss, well, now I know before I even start reading the question that this is really going to be about percentage profit or loss. So I'm not going to be too concerned with actual dollar values. I'm going to be more interested in the percents, because I know ahead of time going into it that that's what we'll be solving for in the end of the day. So to the extent that that's helpful, right, just to get some context and some kind of preview as to what we should be focusing on and what we shouldn't be focusing on, then yes, glancing at the answer choices is a good idea before we read the question. But to start comparing the numbers inside the answer choices and seeing, oh, I've got 80% in one answer choice and 20% in the other answer choice. And I know that 80 plus 20 is 100, so that's a whole percentage. And therefore, those two answer choices are more likely to be right or less likely to be right. No, I don't believe in that. I think that the creators of this test are sophisticated enough to cancel out any kind of strategies like that. So I'm not a fan, no. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.